And now it's time for
a tiny bite
of knowledge.
Jodi, let's make precision agriculture easy for everybody out there.
Okay.
When you're out by a pothole, the area that's super salty and like drowns out and salts out like all the time, does that yield the same as like further away from the pothole where the ground is really good?
Nope.
Very different. Why would you treat them the same? That's precision agriculture in a nutshell right there, right?
Absolutely.
On today's Tiny Bites, we're talking about yield goals.
So, Sarah, fantastic point. When you're thinking about variable rate, anything, any inputs, what's typically the first thing you think about?
It's always the yield goal across the landscape. It's always asking the farmer, what parts of the field yield the best? Which parts of the field yield the worst? And why? Help me understand. And then assigning the correct yield goals in those spots. Fields are never the same across the landscape. It is not normal for us to find a field where the yield monitor never changes as you drive across the field. There's a lot of different reasons why that could be, but generally speaking, we're always going to find that yields will be different in different parts of the field. And so I'm always trying to think about setting realistic yield goals for the different areas of the field.
So, realistic yield goals, how do you typically think about that and come up with the yield goals that you use to create your variable rate maps?
Generally speaking, there's a few different ways that we can think about this. What I really like to do is work with historical yield data that has been well calibrated, might I add, and combine multiple years worth of history by the crop to find out what areas consistently yield greater, what areas consistently yield lower. Based on that, if we've got that yield goal potential with that combined yield history in it, I will use those data against the grid soil sampling data to help us understand what needs to be put out there for fertilizer based on that interaction between that variable yield goal and the grid soil sampling results that are coming back. Further, if it's a zone field, if we're managing our variability with zones, we'll assign variable rate yield goals by the zone. So a zone can have its own yield potential. And this makes total sense. Let's think about corn, for example. You might have zones that are only going to produce 60 or 80 bushels. If it's a super droughty hilltop, or if it's a really low-lying area by a pothole that's got a lot of salt issues in that area, you might not have that great of yield potential. But in that same field, in the very productive areas, you might have a yield potential of 220 to 250 bushels. And yes, I've seen that kind of variability before. Oftentimes, I end up getting concerns from farmers where they're concerned that if they're setting that 80 bushel yield goal for that low, that it's too low and that they might be restricting the yield potential in that area. Well, if you take a look at your yield data over history for the multiple years going back, and you see that you are never really getting above that area, that 80 bushels, why would you fertilize for anything more? Let's be realistic. But at the same time, if the average yield goal for that whole field has been 180, that area out there where you can get 250 might just not be getting what it really needs. Interestingly enough, oftentimes when we start doing soil sampling from a precision agriculture standpoint, we can actually see some of this happening too. So oftentimes when we first set up a field in zones and it goes out and gets zone soil sampled for the first time, we will see large amounts of the non-mobile nutrients like potassium and phosphorus accumulated into those areas with low yield potentials. Whereas when you go up to the really high producing areas where all those big yields come off of, a lot of times we will see lower non-mobile nutrient content like phosphorus and potassium in those areas because it's all been mined out. You've gotten those big yields. Now you're mining out those nutrients out of that area.
So that makes a lot of sense. So like say if you've been applying a flat rate of a fertilizer like MAP or 1152, which contains phosphorus, and you've been just applying it as a flat rate across the whole field. In those areas that have the lower yield potential, like next to a salty spot that just doesn't grow much, if you soil sample that spot compared to like your high yielding area, you're going to find that the area that doesn't have a whole lot of crop hasn't taken much phosphorus up, and you've got a high level of phosphorus there. Whereas you go to the areas that have that higher yield potential and don't have much phosphorus there because that's all been mined out. It just makes sense when we have these differences that we're going to have different levels of available fertilizer once we go and start soil sampling these areas. So that once we do have those results back, we can go back and in the future tailor our variable rate fertilizer maps so that we're only applying what we need in those areas versus what we don't. Making sure that we're not just flat rating across the whole field because we've got high spots, we've got low spots, we've got high yield potential and low yield potential. Every part of the field doesn't need to be treated the same when it comes to phosphorus fertilizer.
Exactly. You nailed it on the head.
So Sarah, say if I'm somebody that only does composite soil sampling and I have that result from last year and I want to do variable rate, is there something I can do to make a variable rate map for the next year?
Yes. As a matter of fact, oftentimes when we are working with a brand new client, they come to us and the only thing they have for soil sampling data is a composite sample. And so with that, we have to figure out a way to do variable rate application. And we accomplish that with variable rate yield goals. By design, a composite soil sample should tell us what the average soil sample value is across the field. Okay. So when we start having conversations with farmers about what is the real yield potential in your low producing areas versus your high producing areas, we can use that average value. It's not going to be exact by the zone or by the grid because we don't have that data, but at least it's a guide that we can go on that'll give us an idea. And then we can variable rate that based on what the production is that we're going to remove from the field. It can still help us manage our cost. And for the farmers out there that get concerned about the fact that maybe that red area is only producing 60 or 80 bushels of corn in that area, I've worked with farmers in that scenario and they get really concerned that they're going to limit their yield potential in that area. And the truth is, if that is really what you're producing, be realistic in that and assign that for that yield goal. The purpose of precision agriculture is not necessarily to increase your yields. It's to be efficient in your production. That means in those areas with the low producing spots, you're probably going to reduce the amount of inputs that you put in there. But likewise, in those higher producing areas, you might take a look at some of those fertilizer rates and go, whew, that's a lot higher than I thought. So it's interesting because the purpose is to be efficient with our inputs. Manage the cost where it makes sense to manage the cost. Give those good producing areas what they need to produce the good yields. It all starts with realistic yield goals and variable rate yield goals across the field.
I think this conversation yielded a lot of great information. Thank you so much, Sarah.
I agree, Jodi. Thank you so much.
Tune in next time for a tiny bite of knowledge from GK Technology, where we have a map and an app for that.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.